Hi, the topic is analysis of algorithms. So in this tutorial, we are going to see how to analyze an algorithm based on some parameters, right? As you write an algorithm, you must analyze it and use the efficient one. Since given a problem, we have many solutions, right? So you need to analyze your algorithm and then conclude on the efficient one. So let's go ahead and see what it is analysis all about, alright? So there are two fundamental parameters based on which we can analyze an algorithm, alright? So the analysis is a process of estimating the efficiency of an algorithm. So there are two fundamental parameters: the time complexity, which is nothing but the time complexity is a function of input size n that refers to the amount of time needed by an algorithm to run to completion, right? So that's what we can say about the time complexity. Now the space complexity is nothing but the space, it can be understood as the amount of space required by an algorithm to run to completion. Those are the two fundamental parameters, as far as analysis of an algorithm is concerned. We must analyze in perspective of those two parameters. So let us understand with an example. All right, so suppose there is a problem to solve in computer science, and in general we solve a problem by writing a program. So if you want to write a program in some programming language like C, then before writing a program it is necessary to write a blueprint, in an informal language. So, or in other words, you should describe what you want to include in your code in English-like language for it to be more readable and understandable before implementing it, which is nothing but the concept of algorithm. So in general, if there is a problem P1, then it may have many solutions, such that each of these solutions is regarded as an algorithm. So there may be many algorithms such as A1, A2, AN, and AM, alright, as you can see there. So before you implement any algorithm as a program, it is better to find out which among these algorithms are good in terms of time and memory. So it will be best to analyze every algorithm in terms of time that relates to which one could execute faster, and memory corresponding to which one will take less memory. But one should keep in mind that we cannot minimize both time and space. So if you need your algorithm to run faster, then you need more space, and the vice versa. So the design and analysis of algorithm talks about how to design various algorithms, and how to analyze them. So after designing and analyzing, choose the best algorithm that takes at the least time, and the least memory, and then implement it, as C programming if you want. So in this tutorial, we will focusing more on the time rather, and the upcoming tutorial, we are going to focus more on the time rather than the space, because time is instead a more limiting parameters, in terms of the hardware. It is not easy to take a computer and change its speed. So if we are running an algorithm on a particular platform, we are more or less stuck with the performance that platform can give us in terms of speed. However, on the other hand, memory is relatively more flexible. So we can increase the memory as when required by simply adding a memory card. So we will focus on time, right, rather than the space. So the running time is measured in terms of a particular piece of hardware, not a robust measure. So when we run the same algorithm on different computer or use different programming languages, we will encounter that the same algorithm takes a different time. right? So that's all what we can say as for now about analysis of algorithms. So it's very important. Okay, so let's actually, of course, as we move forward, we are going to get that into, okay, the better. So now, generally, we make three types of analysis, which as, okay, are as follows. Worst case time complexity. Okay, so what is the worst case time complexity? For n input size, the worst case time complexity can be defined as the maximum amount of time needed by an algorithm to complete its execution. Thus, it is nothing but a function defined by the maximum number of steps performed on an instance having input size of n, right? So that's the worst case time complexity. So, of course, as we move forward, we are going to get into more detail, okay, as far as that those topics are concerned. We also have the average time complexity. For n input size, the average case time complexity can be defined as the average amount of the time needed by an algorithm to complete its execution. Thus, it is nothing but the function defined by the average number of steps performed on an instance having an input size of n. Okay, so suppose that we have an array. Okay, if you're already familiar with an array, we want to find an element. Okay, an element. It may happen that that element is at the last position of the array. Okay, in that case, we talk about the worst case. Okay, average, it may happen that it is somewhere, okay, at the middle. Now the best time complexity, that is, for n input size, the best case time complexity can be defined as the minimum amount of time needed by an algorithm to complete its execution. Thus, it's a nothing but a function defined by the minimum number of steps performed on an instance having an input size of n. Right? So that's all about the, okay, worst case, average case, best case. As we move forward, we are going to, of course, practice so that you get everything. Okay, see you then. Bye.